We're going to start Chapter 3, which is all about probability. The first section is Section 3.1. This is the fundamentals or basics of probability, and this is part 1 of this section. For every random experiment, which is a process with a random outcome, like flipping a coin or rolling a six-sided die, the set of all possible outcomes is called the sample space, and we denote the sample space with a capital S. The elements of S are called outcomes. For example, suppose we flip a coin 2 times. Let's write out the sample space. So the sample space is the set of all possible outcomes. What could happen if we flip a coin 2 times? Well, if we flip a coin 2 times, we could get tails, tails. Or we could get a tails first, followed by a heads. Or we could get a heads first, followed by a tails. Or we could get 2 heads. So this is the sample space. I'm letting H represent heads and T represent tails. So I've just written all of the possibilities as TH, HT, TT, HH. Those are all the possibilities. There's 4 of them. And I'm writing this out as a set. And this is called the sample space. And you can see there are 4 elements in this sample space, or 4 outcomes. Now, an event is a subset of outcomes in the sample space. Events are usually denoted by a capital letter like A, B, C, D, and so on. Suppose we flip a coin 2 times. Let A be the event we land on heads exactly 2 times. Let's list the outcomes in A. So we flip that coin twice. The only way that we're going to get 2 heads is out of those 4 outcomes we listed, there's only one of them with 2 heads. This one right here, HH. Now, what is the probability of this event? So the probability of A. So the probability of A, we denote it as P of A, so we put in parentheses A. It's given by this formula, where we count how many outcomes are in the event A, and we divide that by the total number of outcomes in the sample space. So we set that A, which is the event we land on a heads exactly 2 times, there's 1 element in A, and there's 4 elements in S. So the probability that we land on a heads exactly 2 times is 1/4 or 0.25. You could also say there's a 25% chance that we will land on heads exactly 2 times when we flip a coin twice. All right, so we flipped a coin twice. Let B be the event we land on heads exactly 1 time. Let's see if we can list the outcomes in B. So to land on a heads exactly 1 time, well, we could land on heads the first time followed by a tails, or we could have landed on tails the first time followed by a heads. So out of the 4 options, there's only 2 where we land on heads exactly 1 time. Now the probability of B is 2 out of 4, or 1/2. This is the same thing as 50% chance. So there's a 50% chance that if we flip a coin 2 times, we will land on heads exactly 1 time. Let's try a new example. Suppose we roll a 6-sided die once. Let's write out the sample space. What are all of the different possible outcomes that could occur when we roll a 6-sided die once? Well, we can land on the number 1, we can land on the number 2, 3, 4, 5, or 6. So there are 6 elements in the sample space. Now, if we roll a 6-sided die once, what's the probability that we land on a 4? If we allow A to be the event we land on a 4, there's only one way to do it. And so the probability is 1 out of 6. And if you put that in the calculator, it's about 0.167. Now, what's the probability if we roll a 6-sided die once, we land on an even number? Now, an even number is any number divisible by 2. So let's list out all of the even numbers. 2, 4, and 6 are even, while 1, 3, and 5 are odd. Half of the numbers on a die are even, so the probability of landing on an even number is 1/2, or 0.5. Now, what's the probability we land on a 7? In this event, landing on a 7, that's impossible. So there's no numbers in the set, the sample space, that are 7. So this event has no numbers in it. And so the probability is 0. What's the probability if we roll a 6-sided die once, we land on a number less than or equal to 6? Well, all of the numbers are less than or equal to 6. So the probability is 6/6, which is equal to 1. There's a 100% chance that we will land on a number less than or equal to 6, and there's a 0% chance that we'll land on a 7. So from the last example, you can see that probability is always a number between 0 and 1. If the probability is equal to 0, that means an event cannot occur. While if the probability is equal to 1, that means the event must occur. The closer we are to 0, the more unlikely the event will take place. While the closer we are to 1, the more likely the event will take place. Now let's talk about the complement of an event. Let's say we have an event A. The complement of that event is the set of all elements in the sample space that are not in A. So here I have a Venn diagram. I'm letting this box be the sample space, and A is an event inside of the sample space. And I want to shade a complement. So again, that's everything that's in the sample space, but not in A. So this in purple is a complement. Suppose we roll a 6-sided die once, and A is the event we roll a 4. Let's see if we can put into words what a complement is. So a complement is the event we do not roll a 4. What lives in a complement is all of the numbers other than 4, so 1, 2, 3, 5, and 6, and the probability that we roll a number other than 4 is 5/6, because there's 5 numbers that live in this event, and we divide by the total, 6. Suppose we roll a 6-sided die once. Allow B to be the event we roll an even number. What is B complement? So B complement is rolling an odd number. The odd numbers are 1, 3, and 5. And the probability of B complement is 3/6. Let's try another one. So we're going to roll a 6-sided die once. D is the event we roll a 4 or bigger. What is D complement? Let's put it into words. D complement is the event that we roll a 3 or smaller. So D complement is the set of 1, 2, and 3. That's half of the numbers on the die. And so the probability that we roll a 3 or smaller is 1/2. Sometimes we're going to be interested in the event A or the event B occurring. In math, when we say or, we mean that A can occur, or B can occur, or both A and B occur. Let's look at an example. Suppose we roll a 6-sided die, and I'm going to let A be the event we roll a 3, and I'm going to let B be the event we roll an even number. What's the probability of A or B? Now, mathematically, A or B, we write a union, so it looks like a U. That's a mathematical symbol that represents the word or. So what is the probability of A or B? So that is, what is the probability we roll a 3 or an even number? So here's the event A, and here's the event B. And by joining these two, we get the set 3, 2, 4, 6. So this set is the set of all elements that are 3 or even numbers. There's 4 elements here, so the probability of A or B is 4 out of 6. Now, events A and B are what we call mutually exclusive. That means they don't have any outcomes in common. There's nothing that lives in set A that also lives in set B, and there's nothing in set B that lives in set A. Another word for mutually exclusive is disjoint. So we can say these sets are disjoint, or we could say these sets are mutually exclusive. Here I have a Venn diagram. I have set A and set B, and notice that they do not overlap. Mutually exclusive, we said, means they don't have anything in common, so they're not going to overlap. When we have mutually exclusive or disjoint events, the same meaning here, mutually exclusive is disjoint, then both events cannot happen at the same time. We have a rule where we can make an or statement, the probability of A or B, into an addition statement. So the thing is, we have to first start with 2 events, A and B, and we assume that they are mutually exclusive. So these 2 events don't have anything in common. So if we have 2 mutually exclusive events, then the probability of A or B is just equal to the probability of A plus the probability of B. This formula you're going to need to memorize. Okay, let's say that we have this set, the set of numbers 1 through 10. That's our sample space. And allow A to be the set of numbers 2, 4, 5, 6, B to be the set 1, 7, 8, and D to be the set 2, 7, 8, 10. What is A or B? Can we write it as a set? So take a second and see if you can find the set A or B. So this is the set A or B. It's the numbers 2, 4, 5, 6, 1, 7, 8. So the word or just means that we're joining the 2 sets together. Let's try to find the set A or D. So take a minute and see if you can write it down. Okay, so A or D is the set 2, 4, 5, 6, 7, 8, 10. Notice that A and D are not mutually exclusive. They have something in common. The sets A and B do not have anything in common, but A and D have the number 2 in common. When we have a number in common, we do not repeat it. We just write it once because it only occurred once in our sample space. So this is the set A or D. And the probability that A or D occurs, we just count how many things are in A or D, which is, I think, 7. And we divide by the total number of outcomes in our sample space. And at the top, it says our sample space has 10 numbers in it. So it's 7 out of 10.